Okay, so let's talk about mineral color. Now, you might think mineral color is a good, simple characteristic to use for mineral identification. After all, minerals exist in all different colors. Why not use that as a jumping off point? But the fact is, there's a problem. There's a problem with using color to identify minerals, and let me explain what that problem is. Take a look at this necklace. The beads that make up this necklace are all made of quartz. That is to say, they are all the same mineral. So clearly, quartz exists in a variety of colors. And so I can't count on quartz being white or blue or green. It could be any of those colors. That poses a problem for mineral identification. Similarly, take a look at these minerals. I think you'd agree they're all purple in color. But the fact is, each of these is a different type of mineral. And so using color is not a reliable characteristic for identification.
So how do we measure the hardness of a mineral? Well, in order to do this, we need a piece of glass. Now, glass has a hardness of 5.5. It falls in the middle of the Mohs hardness scale. And I will take a mineral sample. This is a piece of potassium feldspar, and I will try and scratch the glass with the feldspar. In order to do this, you have to have the glass flat down on the table, and you take your sample and you have to push. Not only are you looking for scratches on the surface, but you're also trying to listen and feel to see if the sample is grinding into the glass or not. If it does scratch the glass, then this mineral has a hardness greater than 5.5. If it does not scratch the glass, then it's less than 5.5. Luster refers to how light reflects off of the surface of a mineral. For our class, we will be using two types of luster, metallic and non-metallic. Metallic minerals have a metallic appearance. What I mean is that they are gold or silver and actually look like a piece of metal, like this chunk of galena or this chunk of pyrite. Notice how they look like they are metal. So those have a metallic luster. Then there are other minerals, like this olivine, which does not look like metal, and this has a non-metallic luster, as does this gypsum. It does not look like metal. So when you're doing a luster test, all you have to do is ask yourself, do the samples look like metal? If so, they are metallic. Or do they not look like metal? If so, they are non-metallic. Breakage is probably the hardest property to identify. Minerals break in one of two ways, cleavage or fracture. Fracture is when a mineral breaks randomly. If you look at this piece of olivine, you'll notice it has a jagged, irregular shape. It looks like it was just smashed into a random shape. This is referred to as fracture. This mineral displays fracture. This red hematite also displays fracture. You notice the random, irregular shape. As does this quartz sample, random and irregular, and this pyrite sample, random and irregular. That is fracture. However, there are some minerals on Earth that break in very unique and predictable ways, like this piece of calcite. It almost looks like it was cut this way with a saw, but in fact, this is the natural way that calcite breaks. This breakage is referred to as cleavage. You'll notice it has predictable, flat sides, and if I were to smash this with a hammer, the little pieces that it created would be shaped similarly. This piece of galena has a really interesting type of calcite, has a really interesting type of cleavage. If you look at it carefully, you'll notice that it too breaks at these predictable 90-degree angles, flat sides. This was not cut this way. This is how it naturally breaks. As does this halite. This displays cleavage. There are some other types of cleavage as well. This is called biotite mica, and it looks like a flat sheet. What's neat about biotite mica is you can actually peel off thin pieces of it, and that is a different type of cleavage. I have a piece of peeled off biotite mica here. You notice it's paper thin. This was peeled off of a larger sample. So just to sum up, cleavage is predictable breaking, like this calcite. Fracture is random breaking, like this olivine. Streak refers to the color of a mineral as a powder. In order to make a powdered sample of a mineral, we use streak plates. These are ceramic tiles. One is black and one is white. And what we do is we place them on the desk and we rub our mineral samples against them to create some powder and see what color that powder is. Let me demonstrate. This is a piece of red hematite. I'm going to take this hematite and I'm going to gently, one time, try and draw a line. And what you notice is that it has a reddish-brown streak. I would refer to that as a colored streak. If I try it on the dark plate, I will see it and I can more clearly see the color. So when we do streak tests, we often try it on both the black plate and the white plate. Let me give you another example. This is pyrite. Notice how it looks gold. But when I powder it on a streak plate, it creates a grayish-black streak. Still, it is a colored streak. That one might be difficult to see on a dark plate because it blends in with the background. This is why we use both plates. Other minerals, like sulfur, might give you light-colored streaks, like a yellow streak, which is more visible on a dark plate. Okay. Other minerals might give you no streak at all, like calcite. Does not leave any mark behind whatsoever, even on the white plate. It doesn't really leave anything clear. Maybe a little bit of white, but nothing terribly clear. So when you're doing these tests, you're going to determine, does your mineral leave a colored streak, or does it leave nothing or white? So again, you have two categories, colored or none or white. Beyond streak, cleavage, fracture, hardness, and luster, there are a category of other properties that we might use to identify minerals. And there are a variety of things. For example, this piece of halite could be identified based on taste. Halite is salt, and if you licked it, it would have a salty taste. Please don't lick any of your mineral samples over the next few days. Some minerals have a really unique property, like this piece of magnetite. Now, as the name implies, it is in fact magnetic. As you can see, the paperclip is stuck to it. Other minerals have more unique characteristics, like this calcite. Calcite has two really interesting properties, one of which is referred to as double refraction. If you put it over some type on a piece of paper and look at it carefully, it doubles the type. You notice how the word properties on my reference table here has been doubled as you look through it through the calcite. In addition, if I were to drop some hydrochloric acid on this calcite, it would fizz up like soda. So those are some of the other characteristics we're going to talk about.